is Chapter 5, Systems of Equation for Big Ideas, Algebra 1. This is the review going over sections 5.1, 2, 3, and 4. The first problem says solve each system by graphing. We want to take note on what format these two linear equations are in. Technically, they both are in standard form. Standard form is in the form of ax plus by equals c, where the x and the y are on the left side, isolated on one side, and the constant is on the other. And when it's in standard form, we like finding the x-intercept and the y-intercept. It's very easy because we know when we have the x-intercept, y coordinate is going to be 0, and in the y-intercept, the x-coordinate is going to be in the 0, which ends up canceling out the other term. So when we're looking for the x-intercept, it cancels out the y term. So in our first equation, we'll write that in green, x minus y equals -9. If we cover up the y, we're left with x equals -9, which ends up being the x-intercept. When we cover up the x, we're left with -y equals -9. So we'll divide both sides by -1, and we get y equals +9. So in this equation, my x-intercept is -9. We go on the x-axis at -9. And my y-intercept is +9. We have 2 points. Once we have 2 points, we can draw all the solutions to this linear equation. And it looks kind of like that. We'll correct it a little bit, bring it and align it. So this green line represents all of the solutions to this linear equation, x minus y equals -9. We'll take the other equation, which did we notice that, yeah, it's a standard form, but do we notice that there's only one variable? When there's only one variable, we know that it's going to either be horizontal or vertical. And the trick to this is it's going to go through the y-axis at 5. So we go on the y-axis at 5, and it's going to be a horizontal line. So we know that all of the outputs need to be 5. Let's make that blue. Let's add some arrows to it. So these are all the solutions to y equals 5. Now we look to see where does it intersect. The intersection where it's going to be true, true is this coordinate, and that coordinate's location is -4, 5. So that is the solution that both of those linear equations share. So the solution to the system would be -4, 5. Next problem, we again evaluate what are my, we'll do this equation in green. What are the formats? They both are in standard form, so we cover up. Let's find the x-intercept. We cover up y. That leaves us with x equals -3. If we want to find the y-intercept, we're going to cover up the x. That leaves us with y-intercept equals -3. So -3 on the x-axis, -3 on the y-axis. We will connect the dots to create all the solutions. We'll align those up. And we notice that graphing is not the best. And one of the reasons graphing is not the best is because we are hoping that this intersection of the two lines end up at a grid line. And that doesn't always happen. So if I want to find the x-intercept, I'm going to cover up the y value. We cover up the y value, and we have 2x equals 14. We'll divide both sides by 2, and that gives us x-intercept equals 7. Let's take that away and go back to the original equation. Now if I want to find the y-intercept, I'm going to cover up the x term. That removes the x term, and we're left with 7y equals 14. We'll divide both sides by 7, and we get the y-intercept equals 2. So we'll go back to the original, and that's the easy way of finding intercepts, 2 points, when it's in standard form. X is 7. Whoa, messed that up. X is 7, and y is 2. We'll connect those, making it blue, and we'll look for that point of intersection. Not my best line, and we'll try to line them up. So that is going to be very interesting. Do I want to go down or do I want to go up? That is good. So we can look at the slope of these lines. That's up 2, left 1, 2, 3, 4, 5, 6, 7. So up 2, left 1, 2, 3, 4, 5, 6, 7 would be right here. And then we look at the slope of the green line, up 1, 2, 3, left 3, 1, 2. Let's change the color. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, 3. Yikes, that goes there. So I messed up my points of intersection. Did I do this right? 2 divided by 14 is 7. 7 divided by 14 is 2. X is 7. Y is 2. 1, 2, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7. Yeah. Did I? Oh, well. Oh, there you go. Yeah, hello. If I line them up properly, I will get the proper answer. Just keep working, Mr. Mac. There is our point of intersection. That location is -7 on the x and +4 on the y. So that is the solution to that system. Now we notice this is in slope-intercept form, so y equals -x plus 2. The y-intercept is 2. It's the constant being added, and the slope of the line is -1. -1 as a fraction is -1/1. That means we're going to go down 1, right 1 if we put it in slope form, rise over run. So we go to the y-intercept first, and then we're going to go down 1, right 1, down 1, right 1. We'll make a couple points. Some student wants to join this video. I'm more than happy to allow that student to join my video. If they have a question on something that I'm doing here, by all means, feel free to participate, because I'm sure the people listening may have the same question you do. If you don't have a question, then Mr. Mac would appreciate it being able to continue with his video. The y-intercept is going to be the constant, -4. The slope is going to be the coefficient of x, which is 1. 1 as a fraction is 1/1. Rise, meaning up and down. We go up 1, and run, right, left, you're going to go right 1. Y-intercept first, -4, up 1, right 1, up 1, right 1. Let's graph it. And we connect the dots. Didn't connect them very well. That's a much better connection. Let's draw the arrows to show infinite number of solutions. And what is the point that they share? They share this location, this solution, and that solution is 3, -1. Number 4, also in slope-intercept form. We'll do this top equation, y equals. Now that negative sign is outside, so there's only one negative. You can either put it up on the top or the bottom. I'm going to put it up on the top for no reason other than I can make decisions, being assertive. My y-intercept is going to be the constant, which is -4, and my slope is going to be -3/2, which means down 3, right 2. Now if I put the negative on the denominator, that would be up 3, left 2. Doesn't matter which one, it'll take you to a point on that line. So we're going to plot the y-intercept, and then I'm going to go, well, I don't want to go down. Here's a great reason of why I would do both. Down goes off of the graph, and so it's more conducive for me to go up 3, 1, 2, 3, right, left 2, 1, 2. And remember, our slope is negative, so when we do a negative line, negative slope, it should be, we know what a negative slope looks like. It's going down left to right. So that looks like that. I'm going to put some arrows. And now my other equation is y equals 1/4 x plus 3. My y-intercept is 3. My slope is 1/4. 1/4 in slopes means up 1, right 4. Plot my y-intercept. Again, well, I can go up 1, right 4, 1, 2, 3, 4. Or the opposite would be down 1, left 4. Because two negatives make a positive. And that would be an equivalent fraction. -1 over -4 is equal to +1 over +4. And we see where our point of intersection is. That location, written in a coordinate form, you must include parentheses, -4, 2. So when you give the answer, you have to write it as a coordinate. Coordinate includes parentheses and an x and a y value. Number 5, now, well, the first one is in standard form. You can rewrite it like that. We haven't changed anything. I haven't done anything mathematically. I just wrote the right expression equal to the left expression. And this is standard form. So I'm going to find the x-intercept, cover up the y. If I cover up the y, meaning if I'm left with -x equals -1, I'll divide both sides by -1, and my x-intercept equals 1. So, sorry. And then if I look for the y-intercept, I'm going to cover up the x, and I get my y-intercept is -1. X at 1, y-intercept at -1. Connect them. That looks like that. Pretty good. Arrows. Now, this other equation, -y minus 4 equals 2x. So there's two things I can do. I can move the x over. Getting rid of a positive 2x, I have to subtract 2x. And then I can move the constant over. How do I get rid of a -4? By adding 4, and I get this standard form. And I'm able to easily find the x-intercept, which is -2, and the y-intercept, which is -4. That's why I like standard form. It's very easy. -2 on the x, -4 on the y, and graphing linear equations can be super easy, super quick, as long as you're familiar with the different challenges that assessments tend to give you. So the point of intersection is very apparent. That would be -1, -2. So the answer, -1, -2. All right. Now we're going to move to another technique. The second technique that you're taught is substitution. How do I know we must use substitution? Why is this conducive to substitution? Because one of the variables is isolated. We have this equation where my y variable is isolated in terms of the other variable. So we take this top equation, and the issue is I have two variables. So how can I eliminate one of the variables? Well, by instead of writing y in this top equation, I'm going to substitute its equivalency in x into the top equation. So instead of writing y, we write 2x minus 8, and then I finish with the top equation, equals 19. And why I like this equation better is now there's only one variable, x. We're going to distribute a negative 8. You need to see that negative that's attached to the 8. So we distribute negative 8 times 2x is negative 16x. Negative 8 times negative 8 is positive 64, equals 19. We're not going to move variables or constants just yet. We're going to combine like terms on the same side of the equal sign. That gives us negative 9x plus 64 equals 19. Now we have a two-step equation. We're going to get rid of the constants. And that's going to give me 45, negative 45. And we're going to divide both sides by negative 9. And my x value to the solution is 5. So we just found part of the solution. We know the solution is going to be a location. And I know the x part of that location is 5. Now I need to find the y. How do I find the y? We're going to take this other equation. We can't go into the equation that we used to find x. We can't go into this one. We used that to find the x. So we use this y equals 2x minus 8. And we're going to substitute the 5 in for x. And we get 10 minus 8. And my y location, the y value, is 2. When x equals 5, y equals 2, and that is a shared solution. So if I plugged it back in to both of the equations, it would produce a true statement, telling me that it's a solution to both of those equations. Again, this is nice and conducive. It's isolated. This is really good for substitution. We're going to take that, we're going to substitute it back into the equation. And so instead of writing y equals, we're going to write 4x plus 3 equals 5x plus 5. We're going to move the variables. Always move the variables first. That helps you when things get a little crazy, which they will a little bit later. And negative 2 equals x. So we have a simple two-step equation. This again is my x part of the solution. And now I'm going to take the other equation. I substituted it into the top equation. So I'm going to use the bottom equation. And I'm going to plug in when x equals negative 2. It'll tell me what my y value will be. And my y value will be negative 5. So the solution to the system is negative 2, negative 5. Now, this is not conducive to substitution, but it says I must use substitution. So I have to look at each of these equations and which one would be most conducive to isolate a variable. Well, the top one and isolating for y. So I'm going to take that equation. I'm going to take that, negative 2x plus y equals 4. I'm going to isolate y by adding 2x to both sides. That leaves me with y equals 2x plus 4. I've isolated one of the variables in terms of the other. And I will take the equation that I did not use. Let's do that in green. 3x plus 4. Instead of doing y, I'm going to substitute what this y is equal to. 2x plus 4 equals 16. I'm going to distribute the 4 into the parentheses. 3x plus 8x plus 16 equals 16. I'm going to combine like terms on the same side. 11x plus 16 equals 16. Let's minus 16, move the constants, divide by 11, and x equals 0. 0 can be a solution. That can be a location. So I know my x is going to be 0, and now I'm going to use that in this. 2 times 0 plus 4 equals 4. So when x is 0, y is 4, and that's the solution. And the last example again, okay, I got to pick an equation that I want to isolate one of the variables. I'll choose the bottom one. I have negative x plus 3y equals negative 16. I'm going to move the x over. That gives me 3y equals x minus 16, and then I'm going to move the constant over. Took me 2 steps, but I don't know, it's probably easiest. I isolated for x this time. This is the first time isolating for x in terms of y. I'm going to use the other equation that I didn't, which is the top equation. And, ooh, I like this. It says negative x minus 7y equals 24. So when I substitute this in for positive x, I need to have this negative outside. And then you're left with 3y plus 16, because I want the opposite of what x is. So that was a little tricky. That's probably where many students made their mistake, is they just plugged in the positive x value. If I wanted the opposite of this value, each of the things inside would need to change their signs. And we see that when we distribute the negative in. That's taking the opposite of each sign. So negative 3y minus 16 minus 7y equals 24. Negative 10y, we're going to simplify before moving. We're going to add 16. Negative 10y equals 40. Divide by negative 10. And y equals negative 4. So that's the y value in my coordinate is what I say, negative 4? Negative 4. So the y, remember x, y, don't forget to put the x in the x location and the y in the y location. We can go back to here, and my y is negative 4 equals my x. Negative 12 plus 16 equals x. 4 equals x. So the location is 4, negative 4. All right, elimination. So elimination, again, I don't like the name elimination. I like it's called addition or subtraction or multiplication, because elimination is sort of what we're expecting, we're hoping to do when our objective is to eliminate one of the variables. So when we use elimination or addition and subtraction, we need to first make sure that they are aligned, meaning they have the same variables on the same side of the equal sign and the same constants on the same side. It doesn't have to be in standard form. It doesn't have to be in slope-intercept form. It can be in any crazy form. It's just they have to be on the same side. So if we add these together, we notice that the x's eliminate, and that's why we knew that elimination or addition was conducive. Then we have negative 9y plus 10y, which leaves us with y. 10 minus 12 is negative 2. So that was really nice. So we already have our location for our y portion of the solution. And now I can pick either equation. Doesn't matter, top one or bottom one. I'm just going to pick the top just because it's the top. And we will plug in negative 2 in for the y value to find out what our x value is. We're going to subtract 18. Negative x equals negative 8. We'll multiply both sides by negative 1 to isolate the variable. And we get x equals 8. and I have my solution 8, negative 2. Now this equation is not, if we look at the x's, if we look at the columns do not, no variable cancels. The x's don't cancel, the y's don't cancel. So, okay, that's not conducive for me to do addition or subtraction at this time. But I can find a proportional equation. So proportion is by multiplying all of the terms by a constant number or dividing by a constant number. So we first have to decide what variable do I want to cancel. And let's choose x. Doesn't matter. So 2x and negative 10x. They don't cancel at the moment, but what could I do to the top equation in order to cancel the negative 10x? Well, I'd need the top equation to be positive 10x. So what times 2? Let's actually get rid of this for a second so we can write it. So what times 2x would make 10x, positive 10x? Well, if I multiply it by 5. So I'm going to create an equivalent equation or a proportional equation. 5 times 2x is 10x. 5 times negative 8y is negative 40y. And 5 times 18 is 90. So you have to multiply all 3 terms to keep it equivalent and balanced. Then we just bring over the bottom one. I don't have to manipulate that equation because this is going to cancel. The x's cancel. We're left with negative 36y equals, what's that, 72? And then we divide both sides by negative 36, and y equals negative 2. So I have my y value to my solution. I'm going to pick the, it doesn't matter which equation I can pick. I can pick any of the 3. So I'm going to pick the top one. Oh, let's pick the bottom one because I picked the top one before. So negative 10x plus 4y equals negative 18. I'm going to take my y value and plug it in for y. And I'm going to solve. I'm going to simplify. Whoa. 10x minus 8 equals negative 18. Add 8. This is a 2-step equation. We should be very familiar with this or comfortable with it. Divide by negative 10, and we get x equals 1. So the solution is going to be 1 comma negative 2. Again, we're going to pick a variable. So let's get rid of this part of it. I got to get rid of that number so we can write. So let's get rid of the y's. So we want to find a common multiple. So 3 and 8, 24. So if I multiply the top by 8 and the bottom by negative 3, that will have opposite coefficients for my y variable. So I'm going to multiply everything by 8, which is 56x plus 24y equals 168. Those are big numbers, not fun. Multiply everything by negative 3. That's negative 6x minus 24y equals negative 18. Now we're going to do addition and subtraction. The y's cancel. That leaves me with 50x equals 150. Oh, nice. Divide by 50. Divide by 50, x equals 3. Not bad. We'll take the bottom equation, 2x plus 8y equals 6. Plug in the x value that we solved for. 6 plus 8y equals 6 minus 6. 8y equals 0. Divide by 8. Y equals 0. So we have our solution. 3, 0. Just make sure that you pay attention to which variable for which location of the coordinate. You must solve by elimination. Okay. Okay. Yep. See it? So my x's are really close. They don't cancel by adding. So If I multiply the top equation by -1, that'll produce 5x plus 5y equals -25. We're just going to rewrite the bottom equation, and the x's cancel. I'm left with -3y equals +3 divided by -3, y equals -1. Take any of the equations, -5x minus 8y equals 28. Substitute -1 for y. -5x plus 8 equals 28. Minus 8. -5x equals 20. Divide by -5. X equals -4. So -4, -1 is going to be my answer. All right. On these next group, you can use any method, but you got to show your work. So I'm going to use substitution. I'm going to do a tricky substitution. I'm going to substitute 5y. Now we need to see that it is -5y. So I'm just taking this portion and I'm substituting it in for that part. So that's going to say -4 minus my 5y value, minus 9x equals 0. Raise your hand if you want to join my lecture. I'm more than happy to help you. That's going to be -7 minus 7x equals 0. Always simplify like terms prior to moving. We're going to add 7. -7x equals 7, divided by -7, and x equals -1. Somebody needs to go to the bathroom. We have the x value, -1. What did we do when we were in school back in the 70s? I don't know if the nuns let me go to the bathroom when I wanted to go to the bathroom. They sure didn't let me go get a drink of water. You know when we got drinks of water? At the end of the day. Yep. You think that we had water fountains in Catholic school? We didn't have water fountains. What are you talking about? We had to drink puddles. Just kidding. But that sounds pretty good. All right. Hey. Shh. Shh. I'm recording. Let's use the other equation. I will call you out. You've already apologized to me once. Why are you apologizing to me again? If you keep apologizing, you're telling me that you're not learning your lesson. 5y equals 5. Divide both sides by 5. Y equals 1. So our solution is -1, 1. Love that problem. That's a good one. We talked about efficiency. Can you choose the best, most efficient method? When they do HSPT, SAT, they have two ways that you can do, multiple ways that you can do it. And what they're hoping is that the student takes the 5-minute path. But the student that has put the time in, is well versed at these problems, will choose the 60-second method. And almost every single academic decathlon, HSPT, SAT, PSAT, they all have a 60-second technique. Good luck, yes. All right, I'm going to use addition. This is conducive to addition. The x's cancel. Oh, look what's going to happen. The y's are going to cancel, and we're going to end up with 0 equals 6. Now, are you good enough? Do you recognize, do you recall, do you remember what happens when the variables cancel? Because that's something special. Your lines are either parallel or they're the same equation. And in this case, when the variables cancel and you create a false number statement, the lines are parallel. There is no solution. They do not intersect anywhere, meaning they don't share a common solution. So we have to show our work on this. I want to see the number sentence. When you leave a variable equal to a variable, that is not a number sentence. When you say y equals y, that is not, you have not solved the problem. Do not leave it like that. That's why we move the variables first. Yes, Luke. Oh, I thought it was, you can ask a question that pertains to that. Oh, he's a stretcher. Okay. Head fake on me. We're going to use substitution because I see a variable that's kind of close to being isolated, and we'll just change the method because we already used addition. So we get x equals 2y minus 10. We have a variable that is isolated in terms of the other variable. So we'll take that and substitute it in for x into the other equation. So that leaves us with 3. Instead of writing x, we're going to write 2y minus 10 minus 6y equals negative 30. We love this. That substitution eliminated the x variable and leaves me with only y variables. Now I'm going to simplify. Like terms, they cancel, and I'm left with a number statement, which is a true number statement. And so when it's true, it's infinite. I hate this answer. Infinitely many solutions. Well, in systems, we don't care how many. We want to know the location. Because when there's one intersection, we give the location. It's a coordinate. When there are no points of intersection, we say no solution. When they are the same equation and there are an infinite number of solutions, that's fine, but it doesn't tell us where. So Mr. Mac likes infinitely many solutions, all points on the line, because that's where they intersect. But unfortunately, this math world gives this silly answer, infinitely many solutions. Oh, and we're done. Come and see me if you have questions.